Hello, diamonds in the rough. So in the last video we learned about how we can find the theta, how we can optimize the theta for a linear regression problem, right? Which is a simple problem, and we did it using derivative. But this time I want to tell you an iterative method which is known as gradient descent, how gradient descent work, right? Using the same example. As you can see, the x is the features and the y is the label which we have to find. You have to fit the model, find the theta which fits these data points. And for this one, it is very simple. If you learn about if you learn about function coordinate video, if you have seen that video of mine, we can basically find a slope and just get the equation for this line that will become the theta, and the slope will become theta, and that will our solution. But that is not a very smart way to find the rise and run, because sometime you will not find theta in the straight line. Instead you will have at these points, and then finding a straight line doesn't actually exist. So you have to find very nearest line to these points. So if we have to randomly try this way, we can fit the theta, right? And we have to somehow find this theta where actually it aligns like this and that theta. So the prediction function will basically, as we have learned from the previous video, that prediction is basically take the theta, random theta, whatever you have taken, right, and multiply with the x value, and whatever the multiplication you get, that will become your prediction, right? And the loss, how we can find that how my predictions are correct or incorrect, is basically find the difference between them. If the difference is too much, and if you sum all the difference for all the data points for these, and if the difference is too much, then you have a very high loss. If the difference is good, like very little, then you probably had found the theta which is very good. So let's continue with that. So this is the formula for theta that I have written. Instead of doing modulus, we can actually write square, because they both do the same function, which I have already discussed in the previous video. So sometime we'll denote with predict function, we write p, or sometime we write hypothesis function, which is called h, right, like this. And you do the prediction, you subtract it from the original level, which is y1, y2, y3, and you square it just to get the negative numbers out of the equation. Right, if I more simplify it, this will look something like this. And this is the loss function. If I have to plot this loss function for various theta, right, and our goal is to find this best theta over here, right? One way is, we have already learned, is that we'll assign this thing as 0 and find the derivative, like basically using maximum minima method, right? We can see where the slope is 0 over here, right, and assign it and solve it. That is the previous video I have already done. But this video we're going to learn about iterative method, gradient descent. How can we find theta? So we have to start with some random number, right? And that random number, random theta could be anything, right? And then slowly I have to make sure that I go to around this solution, which is my solution, right? At this point, the theta is at 6 as theta, the loss is minimum, nearby 0. So at this point, somehow I have to reach. So let's say if I start the function from, let's say, 9 point, this 9 point, right? So what should I multiply or subtract or add, what calculation I should do with theta, that somehow, so let's say if I somehow start my random theta with 9, then the goal is to subtract the theta in such a way. And this subtraction, we learned that if we have some function which could tell me how much to subtract in this direction, right? If I could know, how would I know that? And that's how that time I feel very lucky, that if you see this point over here, right? If you see this 9 point, let's say, right? If I can find the derivative at this point, let's say my random theta is this, if I see its derivative, you see the slope is quite high over here. So basically, if my theta is 9 and derivative at this point is quite high, basically if I subtract it, I will probably move toward the direction where my local minimum is, where is basically my theta is optimizing for the least. So in this direction. So if you find derivative at this point, right? If you find derivative at this point, which is basically one way we have learned is like the approximation method is that you just take a small sample area over there, find the rise over run. So let's say for 9 theta, when the theta is 9, you find the loss, whatever the loss you can calculate from here, minus some point 8.5. Basically, this is little difference, this orange difference, right? This orange line in this side, vertical side. So this is this difference. If you do this loss minus loss, you will probably find this thing. And then we have to find this green part, which is basically this little tiny theta, right? And if I divide it, I will probably find the slope, which we have learned already in various videos in our previous calculus series. So you can watch this if you are confused about how to find the derivative at a point. This is approximate method, not the exact one. We'll also see a solution for exact one. So I can find the derivative, and if I solve this thing, right, if I solve this point, if I use this equation and solve it, I'll probably get somewhere around 9 point or something. And then actually I missed one part, is that the missed part is basically that there is a value to be multiplied, right? Which I missed over here. Sorry for that. Yeah, over here we have to multiply with a small number 0.1. Why I told you that? Yeah, this alpha value, right? Why this value is basically, so whenever we are trying to theta, because this slope is a very high number, maybe the slope value could be 4 or 6. So 9 minus 6, if you do it, you will come here some around 3 and you will miss this point. So you want to multiply, and basically this will be a very small number, 0.1 or something, which basically divides that whole, which we don't want. We only want the direction from this derivative. We don't want its magnitude. We just wanted to know which direction I want to subtract theta, which we'll find with the help of this steep value, right? This is the slope of this point. So we don't want the magnitude of the slope. Instead, we want the direction, right? So by multiplying this alpha value, if I assign it to 0.1, basically dividing by 10, so that reduces its magnitude. And because of that, whenever I have to subtract from 9, I don't want to subtract I slowly from 9 to 2, I'll come 8 or 7, and slowly. As soon as I reach 6 over here, the slope over here becomes 0. So whatever the theta it, I will multiply with 0, then this becomes 0. Whole thing, then your theta will not move. It will always juggle around this small point, like around 6.1, 6.2, 5.9, 5. It will always juggle around this place, and somehow it will end over there. And this whole thing is an iterative solution. Like you have to put a loop while programming. You have to put the loop for this one. So that way our solution will come, right? So you have to make sure about that. So that's why we don't want a very big step, we call it step. We multiply the steepness over here with some value, because we only want to use the direction, not the magnitude of that slope, and multiply with this thing. Even over here, we'll see. So this is this method, basically the finding this, what do you say? Loss minus 9 point. Basically it's a finite difference method, which we have solved over there, and we can get our value. I will tell you another value, we'll see. So now after solving theta as a 9, I'll get the next theta as 7. 9 minus 2, it becomes 7, right? So new theta will become somewhere 7. And over here, then I have to find the slope at this point, and basically 7 minus 6.5, that's a slight difference. That becomes 0.1 again. And once you subtract, now theta becomes 6. At this point, I'll get my solution as theta, right? And same thing we can do. Let's say instead of starting with 9, I started with some value over here. Maybe when theta was 3, you can see at this point, right? And then our goal is to go toward this direction. So how we can do that? So if I do again, I'll find the difference over there, finite difference, rise over run, multiply it, it becomes 3 minus 2, I'll somehow come at 4, right? As you can see, at this point, what happened is, if you solve this point, this steepness this is a negative direction, right? So theta is this. In this there, we don't want to subtract. If you subtract, we will go toward this side. So we want to add something to this theta value so that I go towards 6, which is my solution. So because of this slope or steepness is negative, this negative will cancel out, become a positive number. So instead of actually subtracting theta, we actually move towards it. So although our sign is minus over here, but still when we solve it, it'll go towards minimum. So because of this formula, any position I get it always will force me to go toward theta, right? If I'm this side, it will make sure I'll add some value. If I'm this side, make sure I'll subtract some theta value and then solve it. So it becomes 4, and then again I'll repeat this sum process. Once it becomes 4, I'll try to find the steepness at that point at 4 with some small distance. Once I do that, I get the negative number, and soon it will go. And another way of solving is that, if you remember, instead of doing this difference method, we can analytically solve it. Basically, I'll derivate this loss function. If I derivate this 2 will come front over here 2, and we can actually cancel out. We can just throw this, take this common 2, and we can not use it because we only want the direction from derivative. We don't want their magnitude, right? We want only to tell me in which direction the theta has to subtract. Only want direction, not the magnitude. So it was a very hard concept for me. Why we will throw away these 2 values, right? This is a part. So if you are still not able to understand why we throw, or some places you will see the loss function starts with 1 by 2. So whenever we derivate it, the 2 will get cancels over there. So if you haven't understood this, like, keep this question in your head. Once you solve a lot of optimization problem, right, in future you will understand any magnitude values in a cost function, right, who you want to optimize, doesn't help you much. Those magnitude doesn't help you any, right? It's only the relation between, just like in scaling, right? How data point is difference with each other, that matters. Doesn't in which scale they are represented. Same way, if you differentiate this loss function, it will look something like this. And using differentiation, we can find derivative at that point using this method. In a simple way, we can write in a summation form. So this summation could be literally, in programming, you can replace this with some value where these points, like you can loop through these values and then sum it and then multiply by x. Basically, prediction minus actual. If I have to just simplify it, this x into multiply by x1 multiply, this is prediction. This is y1 is basically the actual, the difference, and just multiply with the x values, the feature part. And you can replace this method is more like approximation. This is more analytical and exact solution, so that we can do that. So for new theta, basically you can replace this d loss right over here, and that will also give you a solution, right? I do have a code for this, which you can which I want you to see my course. If you feel like you want the code for this, how you can code this thing in simple thing. I'm starting to have a program, right? Mentoring program. Do contact me on whatever, my LinkedIn, Instagram. You can see that on the channels about section, and try to reach out to me if you are interested about learning machine learning AI. And there I'll share you the code, and you will get one-to-one counseling as well. Because I don't think everybody has a different pace, everybody has a different pace, and they need to have customized education, right? We have tried the class way of learning, and that has failed us terribly. Everybody need a custom solution nowadays. So I'll make sure that you have their custom solution. So you can join me with that course. It will be a paid course. I have already made a video about that, describing how this course will work. So you can join me on that. Here I'll send you the code written for this example, how we can do that. Or you can, I think if you are smart enough, I think you will do it by yourself even. So you can just try to code this code. It's simple, just have some variable, x values, y values, get the solution, create a function for prediction, create a function for loss function, and iteratively do it. And so this way, this is a more actual solution. The other one was more analytical solution. This analytical solution is also used in quantum machine learning, right? So the goal is not to just teach you this thing. In future, when we learn QML, that time I'll refer this video, and so that we can do over there as well. So I hope you have understood gradient descent. This is the formula, and this is a repetitive formula. Theta gets updated, so you have to apply this formula in a loop. And at whatever start point you will do, the slopes will help you to in which direction you have to decrease your theta or add your theta. the slope will help you that. So find the derivative at that point, the random theta which you have chosen. Sometime if you are lucky, you will just likely start with 6, and then this doesn't has to do much, because this differences, this whole thing will calculate become 0.0 something and will not affect the main theta. Learning rate, this is called learning rate, as I've told you. This helps you to decide how big step you have to take, right? So I hope that helped. So that is for today's video. I hope to see you in the next one. Bye bye.